Welcome to our talk. Thanks for attending. We are so excited about being part of the very first KCD Pakistan. Today, we are going to present how you can build your own secure base images using some chain guard tools, APKO and Melange. And we will use Kyvern as a policy engine for runtime verification to ensure that the container image we build uses our secure base image and has a valid signature.
Let's talk about who we are. And I am platform engineer for 3 years at Trendyol, and I am maintaining production level clusters as a platform engineer, and also I am active contributor of various CNCF and Linux Foundation projects. I previously speaker at KubeCon 2022 Europe, and I am so excited to be being part of very first KCD Pakistan event.
My name is Batuhan Apaydın, but everybody knows me as developer guy. I am very active in the software supply chain security space. I am eager to learn more about software supply chain security in all aspects because I know this topic will become one of the utmost topics that everybody has to be concerned. Towards that direction, I won the Best Six Store Evangelist Award and wrote a blog post about it to encourage to the next one and took an active role in first ever Six Store Con by being one of the program committee members of the event. And I am created a community about software supply chain security, and this community is now about 500 people joined. I am also a Docker captain, very first Docker captain from Turkey, and also member of the software supply chain special interest group of CD Foundation. Unfortunately, this one is one of the issues that everyone in the container world was aware of, but ignored until today. Container images are typically built from a base image. So it is extremely important to ensure that base images do not contain any vulnerabilities and are secure. Recently, a company called ChainGuard, the Zero Trust company, researched the popular base images that so many people, including us, are using. Unfortunately, from their study, many popular base images downloaded billions of times comes with tens or hundreds of known security vulnerabilities. That's a lot of security depth in your image to overcome before you even start building your applications. This is a huge problem. In addition to that, many base images also include a fully installed operating system distribution, which explicitly affects the size of the final image. On the other hand, it also increases the attack surface of an image. Another good research by Slim AI was published named Public Container Report. The report shows that 60% of top public containers have more vulnerabilities today than we saw a year ago. In the light of the information above, we understand that we should be careful about choosing our base images for container images. If developers don't choose these base images wisely, it can lead to critical security risks. Is it enough? Of course not. Security is not a static thing. Security vulnerabilities pop up every day, and the image with known vulnerabilities today suddenly becomes a vulnerable image tomorrow. You can't assume that your base images are secure forever. To overcome this issue, we should always scan our base images to identify vulnerabilities and try to make them less vulnerable by applying patches against vulnerabilities before allowing people to use them. In order to secure base images are of high priority, but how can we create build information that contains some valuable information, including which base images were used while building containers? This is where CNCF Sandbox project call and also image specification and base image annotations concept comes in handy. In this talk, we will learn how to build our secure image, how to sign it, how to generate provenance data and capture the base image information from an image and validate that information during runtime. Let's a quick introduction about parent and base images. However, the terms base image and parent image are often used interchangeably in the container community. So we need to understand what base and parent images are. To be more precise, there is no such thing as base for an image because container images can be created or built in lots of ways. So there is not only via Docker file and not only via Docker file that uses from instructions in the last stage. To better understand the base images, we should talk about the layers concept of an image first. Container images are made up of layers, a collection of files and folders built on top of the other and bundle together all the essentials. These layers may be inherited from another image or creating during the build of specific image as defined by the instructions in the Docker file or other build processes. The first layer, known as the base, is the layer on which all different layers are built and provides the basic building blocks for your container environments. Base images provide the base operating system environment for your containers, whether they are built using a Docker files from directive or build packs configured by the run image. Generally speaking, to save the time, we make our container images based on ready-made base images available on various registries such as Docker Hub, GitHub Container Registry, Google Container Registry, and many other public repositories.
Okay, thank you, Batuhan. Let's move on chain guard images. And chain guard images contain only what is required to build and to run your application. And this resolves fewer CVs over time compared to other base images, and on average, an 80% reduction in overall size. And also, chain guard images are a suite of Distroless images that consolidate the base features of the Wi-Fi and distro into end-user container images that can be integrated into existing workflows. And container images are fully declarative and reproducible and include SBOMs that cover all image dependencies. In addition, chain guard images are signed via SigStore, which attests the provenance and all artifacts. All images and corresponding signatures, as well as the SBOMs, are hosted in ChainGuard's OCI registry cgr.dev. To introduce APCO and Melange. And ChainGuard images are built using APCO and Melange combined. These tools provide a reproducible, declarative approach to building OCI images, and it aims to build images from the latest source every night, ensuring that vulnerabilities are addressed as quickly as possible. And Melange on the left side lets you build APKs using declarative YAML pipelines, and APKs are actually APK is a package manager traditionally used by Alpine Linux, and on the right side, APK is tool, basically a declarative APK-based OCI image builder, and APK will take code artifacts built as APK packages and combine them with distribution packages to create a container that has only components that needed to support and a template application. And to build Distroless images with APK, we need to write a configuration file describing which packages should be part of the final image and some additional configuration parameters. And we will see in the demo. Okay, let's move on to the demo. And today we will walk you through how we can prevent containers from running if they are not using one of the allowed base images, and also reject them if they don't provide any build information as well. And don't worry if you don't know how to build information means in this first place, and we will talk about in detail in the upcoming sections, and we will use Kyverno as a policy engine for the policy management on top of Kubernetes clusters and various containers image builders that can provide some base image information in different ways.
First, let's talk about how we can create the build information that contains some valuable information, including which base images were used via container images. But wait a minute, we mentioned that a container image is just a collection of layers. So how do we identify which base images was used during the build? Unfortunately, for any client that pulls your image, there is no way of knowing which base image was used during the build process, which means that once your image is built, information about the base image is completely lost. Fortunately, various container image builders have come to the rescue to address the problem here, such as build packs, Co, and Docker build kit. We will discuss all of them and show how they can provide this information. But today, let's start with Co. Co is a simple and fast container image builder for Go applications. Luckily, Jason Hall, one of the core maintainers of the Co project, worked on an RFC for contributing to Open Containers Initiative, shorthand for OCI. image-spec about adding the base image annotations concept into it. OCI approved his RFC, and now we can add these annotations about image-spec manifest to identify which base images were used during the build, which is precisely what code does for us for free. But today we are going to use three complete technologies. One is Co, another is Wolfie. We are using APQ and Melange. And the other one is Kyberno. So what is Wolfie? Wolfie is a community Linux distro designed for the container and cloud native era. ChainGuard started the Wolfie project to enable building ChainGuard images. Our collection of created Distroless images that meet requirements of the secure software supply chain. On the other hand, Kyberno is a policy engine designed for Kubernetes. Kyberno policies can validate, mutate, and generate Kubernetes resources, plus ensure OC image supply chain security. Today, we will use Kyberno to validate base image metadata information of the images we will build with several techniques. Okay, now let's continue with the demo. First of all, we need to create a Kubernetes cluster, and this is where the kind comes in handy. The next thing that we are going to do is that we need a secure base image, right? In order to do that, we are going to use APQ tool. But this is the APQ configuration file, and in that configuration file, we specify some packages here. We are specifying the repository and the keyring to validate these packages. Basically, as you can see that we are using the Wolfie OS package repository. We are not using the official Alpine repository here for these packages. And you can think of the base image as minimal as possible, because as you already see that these packages contains nearly nothing. They only provide the root file system of our container image, because as you can see that we are putting our CA certificate bundle and Wolfie base and Wolfie base layout. Basically, these three packages provide us a root file system of our container image. And we are specifying a command, and we are just want to build it for suitable with the AMD architectures. This is all that we need to do. But one little note in here, as I am working on my macOS environment, these technologies are as these technologies specific to Linux environment, I need to create a virtual QEMU instance in order to work with APQ and Melange. Luckily, we have some configuration files to do that. Basically, we are going to use Lima CTL to provision these QEMU instances. So this is the command that I am going to run. You can find this APQ playground YAML in the official APQ repository. Once you start this instance, it will come with the APQ installed and all the necessary packages in order to work with APQ. Let's wait it to be completed to continue with the next step. Once this is finished, we are going to build our first secure base image. Once this is done, we are going to use APQ build command in order to output the container image into the disk. So let me shell into the QEMU instance by using limactl shell command. Let's continue with the build command, APQ build. We need to build our secure base image with the command build in APQ. This is the command that we are going to run, and this command will basically output the tar file for us. Then we are going to load it into our Docker daemon, and we are going to retake of image and push it to the Docker hub. So let me basically build my container image. In order to build our container image with APQ, you need to specify the configuration file path and the base image name here, and the directory that you are going to build this tar file. This is the tar file that APQ is going to output. As you can see that it says that its output OC image file to base. tar file. So let me quit this QEMU instance, because once you provision your instances with Lima cattle, this basically maps your working directory with the guest operating system in QEMU instance. So you will basically see that base tire is also existing in my local environment, as you can see here. So this is the next step. We need to load it into our Docker daemon. Once this is done, we need to retag with the proper container image name in order to push to the Docker hub. So let's push it. Let's push back it. Docker image push. Yes. So let's run a grep on the container which we built that we are going to use as base, basically. So let's run the grep command against the container much we built. We are expecting to see 0 vulnerabilities associated with that container image. Nice. This is so good. Now we ensure that this base image has no CVAs related with that. Now we have our secure base image. The next step is going to use that secure base image in our for our container image. This is where co comes into the picture. We are going to use co as we already mentioned that co is a container image builder for Go applications. This is the co's configuration file, and this is the field that we are reference our secure base image here. Once we define that, co is going to use our base image as base layer for our container image. So this is the next command that we are going to run in order to build our container image. Once this is completed, we are going to sign our container images with cosign, because we mentioned that we are going to validate this signature with Kyverno as well. Once this is done, the next step would be signing the image with cosign. This is the command that we are going to run to basically sign the container image we built a while ago. But before that, let's have a look at the manifest of the image we built, because we are expecting to see that the base image reference is included into the annotations. As you can see that basically once we saw these annotations in here, we can say that this image was built by using the base image, and the content SHA of the base image is used during the build process. So this is the where we basically saw this is the image that was used during the build our container image here. So let's sign the container image. We are not going to deep dive into the details of the cosign, but this is the command that we need to run our that we need to sign our container images. As we are using keyless mode, it basically needs to validate our email. So it says that it's pushing this signature. Let's have a look at the entry in the transparency log for our container image. So we need to specify the log index. This is the log index. Yes, this is the entry of our container images for basically say that we sign this image and we store its signature and the content into the transparency log record. So nice. Now we have secure base image, and we use this secure base image to build our container image. So we also signed our container image. The next step is going to verify all these things with Kyverno at runtime. So in order to do that, we need to first install Kyverno. Let's install Kyverno first. Once this is completed, we have 2 policies. Let's have a quick look at these policies. The first policy is basically checks the base image information of the container image we specify. So this is the policy that we are going to use, and you notice that this is the place where you can find base image information. This is the default way of code to define base image information. And we are extracting that information and we are looking for the config map. Is there any match associated with the base image information in the config map? If there is any, we are allowed to deploy this pod that is using our container images, which is using our secure base images. If there is no any secure base images used in our container images, the Kaiban is going to deny this request. So let me quickly apply this policy, and we need to create also the config map. Let me have a look at the config map. Here's the references that we say that this is the image as we specify as secure. All the images that needs to use this image we defined here as base. So let me apply this config map as well. So let me apply the policy. This is the policy, and this is now ready. So let's quickly test it by deploying some image that has no valid base image information included into its manifest. So let's have a run it. As you can see that Kaiban denied this request because BZBug is not using our secure base image. But if we deploy our container images, we are expecting that Kaiban will allow this and pod will be created. So nice. Kaiban, let me deploy this pod because we are using our secure base image to build this container image. So let me quickly remove this pod, because I am going to show you one more example, and this is basically checks our signature we stored in transparency log. This is the image reference, and it's basically verify our signatures that we stored in record. Let's deploy this policy let's apply this policy as well. So let me do one more quick test with BZBugs. Once we try to deploy our BZBugs container, BZBugs pod once again, it will also fail with the check image keyless policy. But if we run our pod with the image we signed a while ago, it basically allows me to do that. That's all for me today. Thank you. Hope you like the demo and the presentation we made with Furkan. Furkan, is anything that you want to say?
Yeah, thank you, Batuhan, and that was a really great demo, and we just demonstrated how the whole idea and seamlessly integrated with each other, and people can also use also implement a similar idea in the production environment or for some real world scenarios. And it was a really helpful and informative for sure.
So thank you. Thanks for attending our talk. Hope you like it.
Yeah, thank you.
See you.